Hi science students, welcome back. Today we're going to focus on isotopes. We know that isotopes are going to be atoms that have a different atomic mass than they normally would. So let's first think about what makes up the atomic mass. We know atomic mass is going to be made up of protons and neutrons. So when we think about our atomic mass, we have to remember that we're including two different subatomic particles, protons plus neutrons. So let's first write ourselves a definition of isotopes. So isotopes are going to be atoms of the same element with a different atomic mass. If you need to pause the video to write this down, please do so. So let's talk about a couple examples. I'm going to do two different examples of isotopes. We know that this atomic mass is not going to vary by the number of protons. If we change the number of protons, we know we change the identity of the element. We change completely what element we're looking at. So we know if we're going to have a variance in atomic mass, it's going to be the neutrons. So it can be either. We can have more neutrons than we would in a neutral atom or less. So I'm going to give you an example of both. So for our first example, I'm going to write example number 1 in the color red. For our first example, we're going to use carbon. So carbon typically has a mass of 12 if you round down to our closest whole number. So I'm going to write that out for myself. Carbon has a mass number of 12 when it's in its neutral form. So carbon has an atomic number of 6. So we know that 6 of those particles in the mass number or in the nucleus are going to be protons, and the other 6 are going to be neutrons. So let's look at an isotope of carbon. So carbon has several isotopes, and one of them is C14. Notice I wrote the symbol of the element dash the number that is now the new atomic mass. So C14 is going to actually have a mass of 14. And when I think about what the difference between this mass and the neutral form of carbon is, I know that that's going to mean that there's 2 extra neutrons. If you need to pause the video to write down this example, please do so. So we've looked at an example where there are extra neutrons. There are more neutrons than there would be in the neutral form. Let's look at an example where there are less. So example number 2, I'm going to do in blue. So example number 2, I'm going to use argon. And argon is a noble gas, which means that it has a full valence, but argon does have some isotopes where it has less neutrons in the nucleus than it typically would. So argon has a mass of 39 when it's neutral. So in this example, we're looking at an isotope where there are less neutrons than there normally would be. So argon 38, or Ar 38, has a mass of 38, which means that there is 1 less neutron than there normally would be. If you need to pause the video to write down this example, please do so. So let's quickly just recap the difference between ions, element identity, and isotopes, and how the different subatomic particles impact the differences that we see in isotopes and ions and different elements. So let me grab a third color to write with, and we're going to draw a little example at the bottom. Scoot you up just a little bit. So I'm going to start by just drawing a really small helium atom. So I'm going to use red for my protons here, and I'm going to put 2 protons in the nucleus. And I'm going to use blue for my neutrons, and I'm just using little zeros to show that neutral charge. I'm going to use black to show where my nucleus is. So this is going to be my nucleus, and then I'm going to create that first level ring. I know that I can stick 2 electrons in there, and helium is going to have 2 electrons, so a minus sign for my 2 electrons. So let's use this to kind of talk about the difference between how the protons, neutrons, and electrons impact how we see the atom. So let's start with protons. We know that protons are going to affect the identity of an atom. So elements are determined by the number of protons So in any case where I'm identifying what the element is, I know I can use that atomic number to tell me how many protons are there, and I know that that's going to tell me what that element is. If I change the number of protons in my nucleus, I am changing the element that I'm looking at. So then let's stay in the nucleus and go on to the neutrons. We know that isotopes, like we just spoke of, isotopes are determined by the number of neutrons. So if I see a variation in the number of neutrons, and it would be written this way with that dash and then the number of the atomic mass, I can still determine how many neutrons are there by taking my new mass and subtracting the number of protons. So taking that atomic mass of my isotope and subtracting out my atomic number. And then lastly, we know that electrons, like we talked about previously, are going to determine ions. So ions are determined by the number of electrons. So if you need to pause the video to get any of this information down, please do so. If not, have a really great afternoon. Bye-bye.